Alright, we're going to look at the three logging rules that we're going to use to condense into a single logarithm and expand into multiple logarithms. So these are actually related to exponent rules. Um, the product rule, when I multiply like bases, I add the exponents. So logarithms are exponents. Here I am adding my exponents. So if I have log of a product, so xy, the implied operation there is multiplication. If I have log of a product, I can break it up into a sum of two individual logs. The quotient rule, when I divide like bases, I subtract the exponents. So here we have some division, and remember logs are exponents, so here we are subtracting the logarithms. Okay. And then the final one is called the power rule. When I have power to a power, I multiply my exponents. So it allows me to take this exponent down and bring it down in the front. And that's going to allow us later on to solve for exponents. We haven't been able to solve for exponents before. So that's something new that we'll be able to do here. Oops. Alright, let's go on to the next slide here. So here we'll just write the product rule for reference. And then we'll work on some problems where we are asked to write as a single log sorry, I don't know if you can hear it, but my cat here is trying to help me. He's very helpful. Here I have log base 10. So we have log of 5 plus log of 3, and they have the same base, so we can go ahead and combine them into a single log. So log of 3 times 5, or log of 15. Okay, pretty straightforward. Usually rewriting as a single log is a little bit easier than expanding. That's the one that students usually have a little bit more trouble with. Alright, let's do log base 3 of x plus 2, log base 3 of x minus 1. And remember, I didn't explicitly mention this before, but in order to use these log rules, they do have to have the same base. So we have base 3 on both of them, so we're okay. So we're going to go ahead and combine them using the product rule. So it's going to be log of x plus 2 times times x minus 1. And then can't forget anything, so we're going to go ahead and FOIL. And then collect our like terms, and that's our final answer. We don't have anything that allows us to break logs up of an argument. The argument's the inside stuff, or the number that has addition or subtraction. We don't have anything like that. So that's our answer. Alright, going on to the next page here. We'll write the quotient rule. So if I have log of the same base and I'm subtracting here, I can rewrite using the quotient rule. So sometimes they might say rewrite as a single logarithm or write as a single logarithm. Same instructions. So remember, the natural log is a logarithm, so it's log base c, and it follows all the rules that regular logs do because it is a logarithm. So now that I have the same base here, and I'm subtracting those logarithms. Sorry, my cat. Alright, so we have a log of 25 minus log of 5, so we can use the quotient rule and rewrite this as a single log as log of 25 over 5, and then we can go ahead and reduce that to just make it natural log of 5. Okay. Let's look at another one. So we have log of x squared minus 4 minus log of x minus 2. The base of the log is 10 in both cases, so we can go ahead and use the quotient rule. And we can write it as log of x squared minus 4 over x minus 2. And then again, we can't forget anything, so we're going to go ahead and factor and reduce. X squared minus 4 is a difference of squares, so it'll factor into x minus 2 and x plus 2. And then we have like factors of x minus 2, so we can divide those out. And we have log of x plus 2. And we can't take this any further because I don't have anything that allows me to break something up if it has addition. Only if it's a product or a quotient inside, or if I have a power inside, will I be able to break anything up. So that's it for that one. Okay. And then on the top here, since we're going to be using the power rule, I'm going to go ahead and write it in. We have log of x plus 5 log of x. Okay, so we have two ways of doing this actually. These are like terms, so I could add them and get 6 log x. That's one way we can do it. The other way, and the way I'm going to show you, is you can put this exponent of 5 back up on using the power rule. In order to use the product rule to combine these into 2, they have to have the same, or they have to have a coefficient of 1 in front, and this one doesn't. It has a coefficient of 5. Alright, so we will go ahead and rewrite that second one. I'm going to put its exponent back up using the power rule. Now using the product rule, we can combine them into a product. And then we have x the first times x the fifth, which will be x the sixth. Okay, and then we'll do 2 more that may or may not explicitly use the power rule, but they're just kind of taking some of the problems to the next level, a little bit more challenging. So here I have ln of 2 plus ln of 3 plus ln of 5 minus ln of 7, and this is kind of a big mess. So what we'd like to do is just to combine it into one single log. Anything that has a addition here is going to be a product, and then the subtraction here, the ln of 7, that's going to go in the denominator. So anything that's positive we'll put in the numerator, anything that's negative we'll put in the denominator. So it's going to be ln of 235 as a product divided by 7. We'll go ahead and multiply the numerator, get 30. I think in class on Friday I may have said it was 60 because I was having a moment there, but it should be 30. Alright, and let's do one more where it gets a little crazier. So 5 log 2 of 3 minus 1/2 log base 2 of x plus 5 log 2 base 2 of 5. Before I can use really any of my rules, I need to use the power rule to put these exponents back up so that I can combine things. So that's what we're going to do here. So we're just going to put those exponents back up. Okay. Alright, now the positive ones will be in the numerator as a product, and then this minus will be in the denominator. One thing to remember, that 1/2 power is the same thing as the square root. So it might be a good idea to make yourself a flashcard or something to remind yourself that 1/2 power is the same thing as the square root. Okay, because 3 to the 5th times 5 to the 5th is going to be 5 to the 15 to the 5th power. That's like a really large number, so we can just leave that as 3 times 5, both to the 5th power, all over the square root of x. All right. So hopefully that made some sense there. This is usually the easier of the batch, and it just takes some practice. And I hope my cat wasn't too much of a distraction. He really likes logs, so he wanted to come help out. All right.